When I'm landing my glider, I've always wondered what my approach path angle is relative to the runway. I know that when I make my turn to final approach, I'm 500 feet above the ground and 1/2 mile from my aim point on the runway. We can use trigonometry to find the unknown approach path angle. Just eyeballing this, I'm estimating the angle is about 10 to 15 degrees because 500 feet is not very large when compared to a 1/2 mile. Therefore, I'm thinking this angle is going to be smaller. Since we have an adjacent and opposite side length to our unknown angle, tangent is the method I will use to solve this problem. If we know that 1 mile is 5,280 feet, then 5,280 feet divided by 2 would give us 2,640. That's what 1/2 mile is equal to. So, now that we know all the information we need to solve, it's just a matter of plugging it in. We have tangent of theta is equal to 500 divided by 2,640. Since we don't know the angle, it would then be arc tangent is set to 500 over 2,640 is equal to theta. Once plugged into the calculator, we get theta is equal to 10.724 degrees. So, my approach path angle relative to the runway is 10.724 degrees. Now that we know the approach path angle, we can also use trigonometry to calculate the distance x to my aim point when I begin my final approach to landing. I know that when I make my final turn to approach, I am 500 feet above the ground, 1/2 mile from my aim point, and my approach path angle is 10.724 degrees. We can use trigonometry to calculate the distance x to my aim point when I begin my final approach to landing. I'm going to estimate this distance as approximately 2,800 feet since the length of my approach path is slightly greater than the track I fly over the ground, which is 1/2 mile or 2,640 feet. We can use sine to find the value of x because x is the hypotenuse of our triangle and we know the side length opposite of our known approach path angle. Since we know all the values we need to solve, we can just immediately plug them into the formula. We know that it is the sine of 10.724 degrees is equal to 500 over x, because 500 is the opposite side length and x is our unknown distance. To isolate x, we would multiply both sides by x, that way it is no longer in the denominator. This would give us x times the sine of 10.724 degrees is equal to 500. Because x is still not isolated, we would then divide both sides by sine of 10.724 degrees, giving us x is equal to 500 over the sine of 10.724 degrees. When plugged into the calculator, we can find out that x is equal to 2,687.042 feet, meaning that the distance to my aim point when I begin my final approach to landing is 2,687.042 feet. I was at the Estrella Classic aerobatic glider competition last month. My friend Bella was executing a loop as she passed over the airfield windsock. I was wondering how far away Bella was from me at that moment. I was standing 2,000 feet away from the windsock and Bella was 50 degrees above the horizon. We can use trigonometry to determine my distance from Bella. Since I was 2,000 feet from the windsock and Bella was 50 degrees above my head, I would expect to find that Bella was approximately 3,000 feet away from me. Since I know the angle between the horizon and Bella and the length of the side adjacent to me, cosine is the correct choice to solve this problem. We already know all the values we need to solve, so it's just a matter of plugging it into the formula. This would give us the cosine of 50 degrees is equal to 2,000 over x, 2,000 being the adjacent side and x being the hypotenuse. To isolate x, we would multiply both sides by x, that way it is no longer in the denominator. This would then give us x times the cosine of 50 degrees is equal to 2,000. However, x is still not isolated, so we would then divide by cosine of 50 degrees on both sides. This would give us x is equal to 2,000 over the cosine of 50 degrees, giving us x is equal to 3,111.448 feet, meaning that at the time that Bella was over the windsock, she was 3,111.448 feet from me.